This is the help video for the Unit 8 study guide. Start reading the instructions both here and the nature of the Unit 8 test is here. This help video does not cover every single problem in your ALEX, only what might be considered the most tricky or most difficult problems. Watch and take very detailed notes. You must also make note of the date and time that you are watching this video, as well as your exact location. What is the area of a triangle? There's two types of area equations for triangles. For any regular old triangle, its area equals base times height over 2. In a right triangle, where you have a right angle, it's leg times leg over 2. So this one on the right is the former. Step number 1 is you must know that that word height always makes a right angle. Height always makes a right angle. Therefore, your first order of business is to draw in your height. Now, there's 3 ways you could draw the height here. Let me just show you. We could draw it there because it's a right angle. I could draw it here. But that's not a right triangle, so it doesn't qualify. It doesn't hit the base. Or I could draw it here. The third way is the most advantageous because you can see it gives us a completely vertical component, which is very easy to find the distance of. So now here, our area equals our base times our height over 2. Our height we've established to be this red. It's completely vertical. So all you need to do is find the vertical up and down distance. And I am starting here, if you look vertically, at 6, and I'm going down to -3. So 1, 2, 3, 4, 5, 6, 1, 2, 3. You can see right now that that height is going to be 9. Base meets at a right angle. Since that's vertical, your base is horizontal. So we are starting here at -6 and going to positive -2. So it's simply 1, 2, 3, 4. So our base is 4. So in order for you to get credit for extra credit, I want you to just take a moment, put a little star there, and I want in your own words, write down one little phrase. What's the number one thing you want to remember from this? In order to get extra credit, you must put that little star there and write what is the number one thing you want to remember from this problem. Short phrase. Says find the area of an equilateral triangle with a side length of 12. Write your answer in simplified radical form. That means no decimals, no calculator. What's really important to understand, because it's equilateral, it qualifies as a regular polygon. So there's two potential equations we could use here. We could treat it as a regular triangle, which would be base times height over 2. Or we can treat it as a regular polygon since all 3 sides are equal. And that one would be perimeter times apothem, and the apothem would go like this, from center to edge. So it'd be the green, perimeter times apothem, over 2. I'm going to show you how to do it both ways. Obviously, on a test, you may decide which direction you want to go. So right here, you know if it's equilateral that these are 60. Which means we have ourselves a 30, 60, 90 triangle rocking right here. That's 30, 60, 90. That would mean this edge here is our short leg. So going to the red would be root 3, going to the hypo times by 2, which means black squiggle, of course, is 6. And the red would be 6 root 3. Coming over here, your base, which is just from here to here, would be 6. Your height, 6 root 3 over 2. Doesn't matter which 6 you take this into. Check units. So that's one way. The other way is to treat it as a regular polygon, pa over 2. So for this one, your 30, 60, 90 triangle would be going this way. You start at the apothem, which is the center, and you go this way. And that is also 30, 60, 90. Let me put the 30s here. So here we would have our, that 6 is now your long leg. Here would be your short leg. So short leg to long leg times root 3, short leg to hypo times by 2. So it would look like this. Your green apothem would read like this. Something times root 3 is 6. That's how that would read. You should recognize the something there is 2 root 3. So now we have everything we need here. You're going to get the same answer. You just need to be familiar with both. Our perimeter, walk it all the way around, is going to be 12 times 3, which is 36. Our apothem right here is 2 root 3 over 2. Students, that was a pause. That was a pause because I'm about to figure out that these two numbers weren't the same. And I know my math is correct down below, so this cancels. We should get 36 root 3, which is accurate squared. So what was wrong with this one up here was the fact that I forgot to trace said base. Even the teacher, if she does not trace, can make mistakes. If I had traced it, like I tell you guys to do all the time, it would be 12, not 6. My base here is 12. Word to the wise, always trace your stuff. Not even the teacher can trust her eyeballs. So we come up here. That base is 12, not 6. That was my mistake. Maybe I did it on purpose to remind you guys to trace as well. So 2 goes in there, 6, and now we're 6 times 6, 36 root 3. Behold, you get the exact same thing. All right, in order for this to count for extra credit, you're going to put a star here, and you're going to pause the video for just a second, and you're going to write what is the one major thing you want to remember from this particular problem. Write it in your own words. Pause. This next problem, this is a composite solid. This is the trickiest of all of them. And remember, when we do composite solids, you follow PET, hashtag, pictures, equations, trace, numbers, PET, hashtag. We have an equilateral triangle is circumscribed, that means drawn around a circle with a radius of 15. Find the area of the shaded region. Give an exact answer. That means, remember the word exact means one or a combo of three things. It means if you have a fraction, leave it as a fraction but reduce. If you have a radical, leave it as a radical but simplify. And if you have pi form, leave it in pi form. Do not multiply it out. So that's what exact means. If you get decimals on this problem, Alex is going to boot you out because you're not following the instructions. Ready? So we're going to start with right here, pictures. To get the shaded region, it's essentially going to be triangle minus circle. Because you see here, if we find the triangle and we find the circle, we can do this. Behold, you have the shaded region. All right, now, triangle. Remember, it's equilateral. Boom, boom, boom. All three sides are equal. There are two equations we could use. Area equals base times height over 2. Or, because it's equilateral, I could use area equals perimeter times apothem over 2. We'll find out in a minute, actually more like 30 seconds, which one's most useful. Circle, of course, is simply always area equals pi r squared. No choices there. Let's come to the triangle and figure out what would be the most useful. So base would be any one of these sides, which we don't have, but we do know they're all equal. So that would be a base. My height, if I were to use it, would go from here straight down. The problem is we don't have a side length to work with. We don't have anything to work with that pertains to this triangle. That 15, you can see, is not double. Okay, so very important, that red is not 30. So we can't use this first equation. There's nothing that we have that is useful for it. So let's see what we could work with. We ask here, do we have the apothem? And wow, we do have the apothem right here. And we need to find the perimeter, which we could easily do. So we are going to be working with this equation. Perimeter times apothem over 2. We have the apothem. It's 15. So that's an easy one. 15. And we actually have also the radius of the circle. If you look very closely, that 15 also qualifies as the radius of the circle. So the circle we could just hammer out of the way right now. There we go, 15 squared times pi. We'll just leave that there. Coming over here, what are we missing? We're missing the perimeter. So we just got one little thing to find here, and then it's going to be minus. How do we do with the perimeter? If you don't know what to do, you look for or make right triangles. Right triangles unlock almost every geometric shape, almost everyone. So that's your first line of defense. So I know my apothem makes a right angle, so I'm going to use that right angle to make a right triangle right there, folks. Behold. I know these corners here are all 60, which means if I come here, that splits the 60 in half. And once again, we have ourselves a 30, 60, 90. Short leg, root 3, short leg times 2. You might be asking yourselves, why do we know that's 60? I skipped that part. If you have 3 equal sides, because of that word equilateral, you have 3 equal angles. 3 equal sides, 3 equal angles. So 180 divided by 3 gave us that 60. This here is our short leg. So short leg to long leg, root 3, short leg to hypo, times by 2. Which means this black squiggle is 15 root 3. This, which is the radius of the polygon, is simply going to be 30. Shrink this back out. Remember, what are we going for? The perimeter. So we go like this. If one edge is 15 root 3, this entire edge is going to be 30 root 3. Root 3 times 3, 90 root 3. We're almost done here. Let's do the circle first. That's easy. You just square the 15. You should have your squares memorized. That's 225 pi. Two goes into 90 45 times. And we now have 45 times 15. Yay, 4th grade math, folks. Those of you that are totally paranoid, doing by hand, I'll show you on a calculator. There you go. So after doing that, we have 675. Don't drop that square root, root 3. Here is what is most important for you to understand. It says exact. Remember, we talked about that, exact. That means no decimals. Look, we got ourselves a radical and we've got ourselves pi form. So your complete answer on Alex, let's see, what are your units here? Units, centimeters. So your complete answer on Alex is literally 675 root 3 minus 225 pi centimeters squared. You are done. This is exact. Exact does not mean rounded decimal. It means leave it as a fraction, radical, simplified, or pi form. Any 3 of those is the word exact. Because this was complicated, we're going to do one more. It's a little bit different. Go a little faster this time. We have an equilateral triangle inscribed, so it's inside now. A circle with a radius of 10, find the area of the shaded region. Let's start with our thing equation. We're doing pictures, equation, trace, numbers, hashtag. So for this one, we are going to do circle. minus. So we have the circle. And then we're going to find the triangle. Circle minus triangle. And when we subtract, that'll give us our shaded region. Circle minus triangle. There's pictures, equations. This one, area equals pi r squared. This one, 1 of 2. Base times height over 2. Or once again, because it's equilateral, it also qualifies as a regular polygon. Perimeter times apothem over 2. Question is, which one do we use? We're going to shrink this in. This one's easy. We have the radius right here of the circle. So this one, super easy. Boom, we just got our circle out of the way. Now let's take a look at our triangle here. Our height, if we had it, would be the red. That would be our height. And our base would be one of these sides. Well, let me trace it so it looks like the height. Most of you see height vertically, so our height would be like so. And then this would be your base. Once again, you see here, you're missing something if you want to do that. That 10 only goes from here to here. So our height is not 20. This would be 10. And then we need right here that little yellow squiggle. We also need the base, so that's not very helpful. So I'm going to not use this one. I'm going to use perimeter times apothem over 2 because that little yellow squiggle is the apothem. And then I'm going to get the blue. We're going to shrink this back in. It's not hard, I promise. 3 equal sides, 3 equal angles. 60, 60, 60, which means this is a 30, 60, 90. Short leg root 3, short leg times 2. Right here is your short leg times root 3 going this way times 2 going this way. Something times 2 is 10 is how that reads. The 10 is the green. And of course, we get 5, which would make this 5 root 3, which would make our entire thing 10 root 3. Now we have everything we need. Our perimeter, we walk it around, 10 root 3, 10 root 3, 10 root 3. Bring it right here. That's going to be 30 root 3 times the yellow apothem, which is 5 over 2. Just need to clean it up just a bit here. 2 goes in there 15 times. 15 times 5 is 75. So your final answer in exact form is going to be 100 pi minus 75 root 3. Let's check for units. Feet squared. That is the exact form. All right, Alex is going to give you a couple solids. They're called composite solids. There's 2 ways to look at this. You can look at it as a single solid and just do area equals base times height. That's volume of any prism, which this is. This is a composite prism. And you do it one time. But the question is, what on earth is the base? That's the method I'm going to use. Alex, if you read the instructions on Alex, and you're welcome, if this makes more sense to you, you can use it. Alex is going to tell you to break this up into distinct, Can you kind of visualize that? Like here you have one rectangular solid, and then you have a second rectangular solid, if you will, and to break it up into two separate prisms. And if that makes more sense to you, by all means, you can use that method. Use the help button on Alex. I'm going to show you my method, which is one shot stop. And so the only question we have to ask ourselves is, where on earth is the base? Back to here. Remember, bases are congruent, parallel, connected by rectangles. Two of them, congruent, parallel, connected by rectangles. So remember this solid? The base here was these two L's. And the reason why is the L's are congruent. They are parallel to each other, and there's nothing but rectangles that connects them. So using that rule, congruent, parallel, connected by rectangles, the bases in this prism is going to be this front and back L shape. Front and back L shape. I'm not going to do the rest of it because it makes, so you can kind of visualize that. I'm not going to shade the back because it gets kind of messy. So this, using my method, is going to be your B. And then height is distance between the, so if the front and back L's are the bases, your height is distance between the bases. So using this method, my height is going to be 6. And my base is this shape. So obviously, it's a composite shape. So we are going to break this base up. It doesn't matter how we break it up. I'm going to break it up. Let's see, I'm going to go horizontally. So I'm going to do this green, break it up this way, and then I'm going to do yellow here. So taking a look at the green. Green, of course, is a rectangle, length times width. Watch very, very carefully, guys. You must trace here. Our length of the green, 10. Our width, warning, is not 6. Our width is from this edge to this edge, which is 4. Coming up here to the yellow, also length times width, but you have to derive it. So coming very close, watch. If this edge is 6, from here to here is 4. I get that from back here. That means this little squiggle here is going to be a 2. And then we know this, pulled from the back, is also 2. So you have to be very observative. So that little yellow is 2 times 2, which of course is 4. So our composite base of this whole thing all together is going to be 44 centimeters square. Boom, there's our base, 44. Now we do 44 times 6. And I know you guys don't trust the longhand, so I'll do it on a calculator as well. 44 times 6, there it is. So our volume here is going to be 264, watch your units, centimeters cubed. Put a little star by this one, once again. Give me a short sentence. What do you want to make sure you remember for this particular problem? Pause the video, write a sentence, then come back. Nope. Wow. Follow me now. Once again, there's 2 ways to see this. Alex is going to have you see it, if you want to watch the Alex instructions, as 3 separate prisms. 1, and then here, rectangular prisms, like this, and then another one. 1, 2, 3. And you'd have to find the volume of all 3 separately, which you are welcome to do so. I'm going to use my method where I see it as a composite solid. So volume equals base times height. My base, again, like this L shape, is a composite solid. You look for something, 2 sides that are congruent, parallel, and nothing but rectangles connecting them. And that would be, in this case, the 2 eyes. The front and back eyes, those are congruent, they are parallel, and there's nothing but rectangles that connect them. So the front and back eyes would be the singular composite base. That's what I'm going to use. And I am going to break it down. So this base I'm going to find this area using what's called negative space, because I know some students see it this way. So for this, I'm going to find the area of this outer rectangle. Just so you can see both methods. So we're going to go like this, that edge to that edge. Watch very carefully. Here to here is 5. Here to here is 8. Here to here is 5. So my one edge there is 18 inches. I go like this, and that's 7. So I'm going to go 18 times 7. 126. And then if you look carefully, we have these 2 tiny little rectangles that we're going to cut out. So we are going to go 126. We're going to cut out these 2 rectangles here. Let's take a look and see what we can do with those. Watch very, very carefully. Let me get rid of all this extraneous stuff so you can see it. Look. From here to here is 7. From here to here is 6, which means this little piece on both sides is simply going to be 1/2. Because it's 7 minus 6 is 1, you split it in half. And then this edge is 8. So this tiny little rectangle, don't freak out with the fraction, it's really not as hard as you think it is. And we have 2 of them, if you will. These guys, 2 of them. So we have 2, and it's 1/2 times 8, which those cancel. Ta-da! So that means our composite base, which is this I, is 126 minus 8, which is 118. And inches squared. So base times height, 118. Height, distance between the bases, which if you're using the eyes, your distance between the bases would be that 2 inch. So we simply do 118 times 2. Is this our last one? I think so. No. Okay. I forgot we haven't done the new stuff. All right, this one's super easy. We're just going to find the volume of the cone. Volume of a cone is super easy. Volume equals base times height over 3. We want exact terms of pi, so no decimals. We are told that the diameter is 6 and the height is 11. Super easy, folks. My base is this circle. So we come here, base, is pi r squared, and our height is right there over 3. So we have pi, our radius is half of 6, which is 3, so 3 squared, times our height, which is 11 over 3. So let me just clarify. This is the base, this is the height, and it's over 3 because it's a cone. So key to multiplying is not multiplying, it's factoring. So I'm doing 3 times 3 times 11 over 3. Don't even need to use a calculator, they cancel. So my volume here is going to be 33 pi inches cubed. Ta-da! You're done, because it's exact terms.
How'd you do that?
Taking a look here. So right here, my base is a circle, pi r squared, and my height is right there. So my base, my radius is 3. So it's 3 times pi. That's my base. You good? My height is 11, and then it's over 3. 3 goes into 3. Volume equals 33 pi inches cubed. Taking a look here, our very last lesson dealt with solids and similarity, and remember what you're looking for is scare for similarity. Specifically this, similar solids have congruent angles, and here's the star of the show, ratios which are equal. That is what determines whether or not solids are similar. And remember, scale factor is ratio of the sides simplified. So coming here, step number 1, you find corresponding lengths, and then we check the ratio. So I'm going to go height to height, 12, 32. Both of those are divisible by 4. So I'm going to see if it matches. 12 divided by 4 gives me a 3. 32 divided by 4 gives me an 8. I can't go anywhere else there. Then I go right here. Watch very carefully. Diameters. So this whole diameter is 4, this whole diameter is 9. Notice the ratio, 3 to 8, 4 to 9, does not match. Therefore, they are not similar. It says right here the heights and the base radii. So we check the heights, 21 to 15. Both are divisible by 3. Now we come here, 6 and 5. Those aren't divisible by anything. Let's check our ratio. I have a 6 to 5 and 7 to 5. Once again, does not match, not similar. Let's check here. We actually have 3 things to check. Here we're going to go height to height, 16 to 12. Both are divisible by 4, of course. Divided by 4, divided by 4. This is going to be a 4 and a 3. Let's check this way. 12 and 9, both divisible by 3. This is 4 and 3. This edge length right here, 4 to 3. Oh, look, it matches. 4 to 3. Notice the ratio is the same all the way around. 4 to 3, 4 to 3, 4 to 3. This one, behold, is similar. Why? Ratios are equal. What is my scale factor? Left to right, 4 to 3. So similar is scare. Congruent angles, ratios equal. Now when things are similar, when things become similar, you need to remember this. When you change dimensions, you change ratios. You change dimensions, you change ratios. So right here, it says a designer builds a model of a truck. The finished model is the same shape as the original. That tells you it's similar. The scale factor is 2 to 5. So I'm going to try to do a little truck here. So you got a little baby truck. Okay, and then you have the bigger version of the said same truck. Try to make this look the same. I am a horrible artist. Okay, when it says the ratio, scale factor is one dimension. Scale factor is length to length. So the ratio of one dimension is 2 to 5. So our one-dimensional ratio is 2 to 5. Is it 15? Oh, good catch, Sean. 15. That makes more sense because it's to real life. Good catch. 2 to 15. Yay for finger tracking and reading out loud. 2 to 15. So height is one dimension. It has the same ratio. Surface area. Surface area would be if I painted the trucks. What is the area that I'm painting and what happens with that area? Well, area is 2D. So what do we do with the 2 and the 15? Because it's 2 dimensions, we simply square it. So that's going to be 4 to 225. So you don't keep the same ratio as you change dimensions. You change dimensions, you change ratios. Volume is 3D. Volume is 3D. That'd be about the amount of space that the truck takes up. So you start with our original ratio, 2 to 15, and now you cube it. So your volume ratio, 2 times 2 times 2, that's 4 times 2, is going to be 8. And yes, you may grab a calculator for 15 cubed. 15 times 15 times 15. 3375. 3375. So the ratio of the area and the volume changes with the dimensional exponents there. Last problem. Gift shop uses 2 sizes, presents for boxes. The boxes have exactly the same shape. That's a hint that we're dealing with similar shapes. So I am simply going to draw 2 little, like, t-shirt boxes. 1, try to make them the same shape here. And they are the same shape, which means they are similar. Immediately, we are going to write right here. What's your 1-dimensional, 2-dimensional, and 3-dimensional ratios? Says the smaller box is 21 centimeters long. The larger box is 24 centimeters long. If you need 1,666 centimeters squared, pay attention to that, squared, needed for the smaller box, that means we're right here, the actual surface area. You did this in the very last video. Surface area is like wrapping paper. Our actual surface area of the smaller is 166 centimeters squared. It's asking how much wrapping paper, okay, I will recap it. Surface area How much wrapping paper do you need for the larger? That's the question. Done with this. Ready? Step 1. We find our one-dimensional ratio, which is the ratio of the sides simplified. Okay, so let's do this together. Kai, what is 21 and 24 both divisible by?
21 and 24?
Yeah, they're both divisible by the same thing.
3.
Mm-hmm.
I was already going to say that.
Yeah, I'm sure you were. So we're going to go divide by 3, divide by 3. Kai, 21 divided by 3, sir.
7.
Okay, 7. 24 divided by 3?
8.
Yes. So our one-dimensional ratio is 7 to 8. Keep in mind, that's the first dimension. Our second dimensional ratio is going to be 7 squared to 8 squared. So our second dimensional ratio is going to be 49 to 64. Our three-dimensional ratio, if we're going to use it, I always just do all three just for giggles, is going to be 7 squared cubed, and 8 cubed. Yes, you may use a calculator. And it's going to be 343 to 512. So the ratio of the areas and the ratio of the volume is not the same as a scale factor. Now, the question is, to solve for the wrapping paper, which one are we using? Wrapping paper is 2 dimensions. We're using this ratio. So watch. We are going to do ratio to ratio equals real to real. Ratio to ratio equals real to real. So our 2-dimensional ratio is 49 to 64. That's small to large. Small, 1,666 over large x. Cross multiply. And we're dividing by 49. Yes, at this point you can grab a calculator. Let's take a look here if it wants any wrapping decimals. And here we go. Doing 64 times 1,666. Where's my equal sign? There it is. Divided by 49. And we find out that we need 2,176 centimeters squared of wrapping paper. Please take a moment, once again, last time, star, and write a quick sentence. What do you want to remember?
Wait, can you go back?